Okay, welcome back. Today we're gonna try to find the following limit. Square root of n plus 1 minus square root of n as n goes to plus infinity. Okay, so basically this is a sequence and we are trying to find its limit as n gets bigger and bigger. We can use some clever way to expect or to see what's the common limit. So here the difference between n plus 1 and n is just 1. So we can think of the square root of, sorry, let me change the pen. We can think of the square root of n plus 1 as the same as the square root of n. Okay? Because as n gets bigger, these two numbers, n plus 1 and n, are almost the same. So we can take a big number like 10 to the power 100 and you add 1 to it, and you take 10 to the power 100 and you see the difference between these two is just 1. Okay? So what's 1 compared to this one? This number. Okay? It's 10 to the power minus 100. Okay? So it's a very tiny number. So that means that as n gets bigger, the square root of n plus 1, it's absolutely almost the same as the square root of n. So here it means that these two numbers will get very close. That means the limit is 0. So based on this, we can say the limit is 0. Okay? But this is not a proof of this result. We need to do more. We need to justify this limit. So the best way here when we have the square roots is to use the conjugate. So that's what we're going to use here. So let's first simplify this expression. So we have the square root of n plus 1 minus square root of n is, let's multiply square root of n plus 1 minus square root of n. Let's multiply the top and the bottom by the square root of n plus 1 plus square root of n. Okay? Here on the top, so we get n plus 1 minus n over square root of n plus 1 plus square root of n, which is 1 over square root of n plus square root of n plus 1. Okay? We can't deduce directly from here. Okay? Or we can use some logic here. So we can say 1 over this one goes to infinity, because this one plus this one goes to infinity, so 1 over infinity is 0. Okay? And we can go quickly about this. Okay? But this is basically based on the fact that plus infinity is plus infinity, because this one goes to infinity, this one goes to infinity, and 1 over infinity is 0. Okay? We can do a bit of work and maybe we can say that we can factor out by the square root of n or n. So we have 1 over n, 1 over n, okay, plus square root of 1 plus 1 over n. Okay? So in this case, we have this one goes to 0, this one goes to 1, and in this case we have 1 over infinity. So it's 0. Okay? So the limit of this one is 0. The limit of this one is 1, and we have this one goes to infinity times 1, which is infinity. So we have 1 over infinity, which is 0. We could have deduced that from here. So we said the limit is 0. because 1 over plus infinity is 1 over plus infinity, which is 0. So this is I did a little bit of work, but basically we get the result is 0. And this proves that the limit of this difference of radicals is 0.